Chapter 2 is about displays of data. In 2.1, the book talks about an expanded frequency table. In 2.2, they discuss the histogram, which is based on a frequency table. And in 2.3, which talks about other graphs. Like Chapter 1, many of these things you should recognize and mostly know how to use. This chapter fills in the missing pieces and names the displays and graphs. For this chapter, I chose the theme of sports, which use a lot of statistics. The table below is an expanded frequency table for number of aces in NCAA women's volleyball in 2016. You can see each row represents a class, which has a lower class limit and an upper class limit. Each class has a frequency, the number of teams with aces in that class. Each class has a relative frequency, the frequency relative to the total number of teams. Generally, relative frequency is expressed as a decimal, but I thought for familiarity I would use a percent this time. How was the 12.15% calculated? And the cumulative frequency is how many are at or below that class. For example, 56 teams have 144 aces or fewer. How was the 93 calculated? A histogram is based on a frequency table using either the frequencies or relative frequencies, never cumulative frequencies. The histogram here is based on the frequencies of the table above. Notice how there are 6 bars for the 6 classes. The heights of the bars match the frequencies. They may also match the relative frequencies. The classes are labeled on the vertical axis by the limits. Histograms are one of the most important displays of data because you can see the shape of the data. What is the shape of this data? A bar graph is similar to a histogram. The biggest difference is that a histogram is only for quantitative data, while a bar chart is for qualitative data. The difference leads to another difference. In a histogram, bars should touch, while bars don't touch in a bar chart. What is the football bar telling you? A pie chart is probably a graph that you are most familiar with, but it is also the most misused, so please be careful. For example, what does the lacrosse wedge telling you? Be careful. A dot plot is not commonly used with the small data sets we use in this course, but it can be useful for larger data sets. It is also very easy to read. What do those dots above 11 mean? There is also a stem plot and a Pareto chart in this chapter, and a box plot in chapter 3.